Okay, video 2 for lesson 7.2 on these similarity transformations. Okay, so let's take a look at the next slide. So it says find a similarity transformation. So it says why is a PQRS similar to GKJH? So the reason that they're going to be similar is because there's going to be a similarity transformation that we can do to map one onto the other. Right here, a similarity transformation is a composition of one or more rigid motions and a dilation. So notice it's a composition. It involves rigid motions and a dilation. It has to have a dilation because again, when the figures are different sizes, as these two quadrilaterals are, notice, slight different sizes, right? The black one looks slightly smaller than the red one, right? But again, we have to use the dilation to enlarge or reduce, right? So because it gives us this order, let's go this way, all right? So let's try to make PQRS go on top of GKJH, map onto it. So this is difficult because it's going to require two rigid motions and a dilation. Okay, so first off, right, reflection or rotation. Notice they're not oriented the same way. I need P to line up with G. It's not, right? I need S to line up with H. It's not. If I were to rotate it, say 90 degrees, if I rotate it 90 degrees clockwise, right? To me, I could maybe line up P and G, but then R would go to the top left. And I know this is hard to see. I'm just talking out loud. R would go up here to the top left, but it needs to correspond to J in the top right. So I don't think a rotation is needed here. We're actually going to do a reflection, okay? And to make that reflection easier, we're going to do a translation first, because if I can line up one of the points and then reflect from there, it should take care of itself. So the first thing I'm going to do here, so number one, is I'm going to do a translation. So I'm going to translate. And when I do this translation, I'm just going to line up P with G. So I'm going to translate this straight down so that P and G are now the same point. Okay? So P goes straight down, Q goes straight down, R goes straight down, S goes straight down. And again, we do our best to try to keep this the same. And I'll use dotted. Okay, there we go. Okay, so now the second thing I'm going to do is now I'm going to reflect this. And I'm going to reflect across line L, reflect over L. Now, if you look at this, right, because P and G are the same point, or I'm sorry, yeah, P and G, the line of reflection has to go through that point. And then I'm going to kind of just eye it up. Now, again, I'm not going to be able to line up Q and K because they're different sizes. But if I kind of draw this line right around here, and again, don't quote me, right? I'm just doing my best here. If I draw that, call that line L, then what's going to happen is S is going to reflect and it's going to come somewhere here. There's S. R is going to reflect and come somewhere in here. And then Q is going to reflect and go somewhere on this line GK. And now we have that smaller quadrilateral kind of inside the bigger one. Notice that P and G are lined up. So now what I can do is I can dilate from P so that S, R, and G slide away from it and line up on those corresponding points. So the third thing we're going to do is we're going to do a dilation. So we're going to dilate. Now when we do this dilation, the center of dilation is going to be P, right? And now, in order to dilate, we need to enlarge this, meaning that we need to take a bigger length and divide it by a smaller length. Well, we have to use corresponding lengths in this picture. So our scale factor, and again, you can think of it as, in this case, because it's an enlargement, bigger over smaller, or new divided by old. We want this smaller blue quadrilateral to become the bigger red one. So let's just use GH. GH is the longer length, which corresponds to PS in the smaller quadrilateral. If we take PS and multiply it by GH, so over PS, so if we take GH over PS and multiply it by PS, so PS is the original length, this is my scale factor, These will cancel and you'll get GH. You'll get that new length you want. And you'll get S to come here. You'll get R to come here. You'll get K to come here. And then you are right on top. You are mapped on top of the second quadrilateral. And this is why PQRS is similar. Notice the symbol for similarity, right? This little squiggle without an equal sign is similar to GKJH. Okay, so I call these theoretical problems. They're hard to see. Again, I'd much rather do it on the coordinate plane where I have numbers to work with. Okay, so these are just properties of similarity transformations. Again, we're not going to use these very often, but I just want to kind of show you, right? So you have the reflexive property, symmetric property, and transitive property. Again, if you think about when we did proofs, reflexive property, something equals itself. Well, same thing. Similarity, something is similar to itself. Symmetric property we didn't use. Transitive property, if A is similar to B and B is similar to C, then remember with the transitive property, we kind of take out that middleman and we connect the outside guys, right? Okay. So again, that's just there for you because the book thinks it's important. Okay, next, and I think this is the last problem, I think. No, we got two more problems left, sorry. Okay, so the artist problem, and they go back real fast, sorry. I'm working on it, give me a second. There we go. Okay, so it says, can the artist copy her sketch to cover the entire wall, measuring 15 feet high by 20 feet wide, so her wall mural is similar to her sketch? Explain. So we have, this is the painting right here in her arms. This painting is 11 inches high, right, and 14 inches wide. So this right here is the height. This right here is the width. There is a wall, much, much bigger because we're in terms of feet, but I'm going to just draw a wall here. Again, it's not going to do it justice because it's much bigger than the painting. The painting in all reality is like this big, okay? Okay, so this wall is 15 feet high by 20 feet wide. And the question is, can we copy this painting onto this wall so it covers the wall entirely, entire wall, right? Well, what we're going to do here is we're going to look at the height and width of the painting and compare it to the height and width of the wall. And we're going to use a ratio to do this. This is kind of introducing us to what's called proportions and showing that similar figures have proportional sides, okay? So let's take a look at the wall first. So if I do the height of the wall to the width of the wall, that would be 15 feet over 20 feet. Now the feet will cancel, and we simplify 15 over 20 by dividing by 5 on top and bottom, and we get 3 to 4. So the ratio of the height and width on this wall is 3 to 4. Now, let's apply this same thing to the height and width of the painting and see what we get. Well, let's go height over width. That would be 11 inches over 14 inches. So the inches would cancel. Now, unfortunately, 11 and 14 are not divisible by the same number. So if I were to divide 11 and 14, what I would do is I would get 0.785, blah, blah, blah. Well, 3/4, maybe you know, is 0.75. They're not equal. Therefore, the wall and the painting are not proportional. And because they're not proportional, they're not similar. So because the sides are not proportional, the wall, so sides are not proportional. Maybe I should do like an arrow. I'm sorry. The wall and painting are not similar. And therefore, because these sides are not proportional, and because the wall and painting are not similar, you cannot cover up this entire wall with the mural. Okay, last problem coming, I think. I hope. Let's see if I can make it happen. All right, I can't. Okay, here we go. So it says identify similar circles. So this is actually a huge deal to the state test. You will see this on the state test once or twice. It says write a proof that any two circles are similar. This is an idea that is true, and the reason is, right, because all circles are the same shape. They're all circular. Now, they have different sizes based off their radius, but they're all the same shape. Okay, so we have circle P, circle Q. We want to prove that circle P is similar to circle Q. So the first step here is we want to line up the centers. We want them to be what we call coinciding, right? The same point. So this can be done by a translation, a reflection. I'm just going to do a translation. So we're going to translate, and we're going to translate so that P becomes Q. So we're going to slide this way so that this point now is P, and so the circle P, is going to be centered inside that circle, still having a radius of R. Okay, we call these now concentric circles. So we want the circles to become concentric. Concentric means same center, concentric. So then step 2 is now we need to dilate, right? We need the radius of the circle P, the small circle, to increase. So when we dilate, our center is going to be P, and our scale factor, again, is going to be new over old. Or, in this case, because we need to enlarge, it needs to be the longer measurement divided by the smaller. Well, in this circle, S, circle Q, S is the longer radius, and R is the smaller radius. And again, if we take that smaller radius, R, and multiply it by the scale factor of S over R, the R's cancel, and we get S. And that will then increase this radius to a length of S. That will then increase the circle, so that circle P is now on to circle Q. So now circle P will be similar to circle Q. And there we go. All right, great. Again, this is not an easy section. Do your best. Thanks for watching. We'll see you in class.